morning children. Today we are going to learn in the states of matter the properties of substances. So when we consider the solids, liquids and gases, they have got some property in common. The first one that we are going to consider is the thermal conductivity. What is thermal conductivity? It is the measure of a material's ability to conduct heat. So that property is called as thermal conductivity, and all these properties, whatever it is, they are all based on the arrangement of molecules in solid, liquid and gas. So when we are going to study all the properties of these substances, again we have to go back to the arrangement of the particles in the solids and the liquids and the gases. How these particles are arranged in case of the solid and in case of the liquid and in case of the gases. So here when we are going to consider the solid, liquid and the gases, the particles, how they will be arranged? In case of the solids, the particles are tightly packed. So again, whenever we are going to study any of the property of the matter, that is solid, liquid and gases, we should not forget this arrangement of the particles. In case of the liquids, the particles are away from each other, but in case of gases, it is much more away from each other. Because of that one, all these properties we are going to study. So here, when we consider the thermal conductivity, what we are going to do? We are going to heat a substance. Heating the substance means heat is a form of energy. So we are providing energy to the particles. When the particles are going to get energy, they transfer energy from one particle to the other particle, whether it is a solid or a liquid or a gas. Then we are going to say that that object is able to conduct heat. In that way, when we are going to consider the thermal conductivity, again the matter or the substances are divided into two types. First one, it is called as good conductor or conductor of heat simply, and the next one, it is called as bad conductor, or what we are going to call it as insulators. And all these properties of the matter we are using in our day-to-day life. So what are good conductors of heat? The substances that carry heat are called good conductors of heat. In the same way, the substances that do not carry heat are called as insulators or bad conductors of heat. So here, when we are going to consider the conductors, any material that allow, here it is given for electric conductivity. In the same way, when it is given to carry the heat, they are called as good conductors of heat. In the same way, bad conductors of heat. So here, when we are going to consider the spoon, it is made up of steel. So steel is a good conductor of heat. In the same way, when we are going to consider the copper is also a good conductor of heat. But when we consider the glass, it is a bad conductor of heat. And this wood, it is a bad conductor of heat. In the same way, the plastic is a bad conductor of heat. So, if you are going to fill water in the beaker, and then if you are going to keep all these things inside, and then if you heat the water then we will be easily able to carry this one out and the plastic also. But what about this one? We cannot take this out by this one. What we do? We are going to take a cloth and then we will lift it. So by this one we will come to know that the substances, some of the substances are bad conductors of heat. The example for that one, it is wood is a bad conductor of heat, glass is a bad conductor of heat, plastic is a bad conductor of heat. In the same way, good conductors of heat, example for that one, commonly all metals are good conductors of heat. In that one, we are going to consider copper, aluminium, steel, iron and so on. If you go on listing them, they are all good conductors of heat. Then the next one, because of this property of the conduction of the metals, in our houses we are using the vessels that are made up of steel, and the cooker what we are going to use, it will be made up of aluminium, and also we are using the copper bottom vessels because copper is the good conductor of heat. The second property is electrical conductivity. So what is electrical conductivity? Ability of a material to conduct electricity. That is called as what we are going to call electrical conductivity. In the electrical conductivity also, as we are going to say here, good conductor of heat, here also we are going to consider good conductor of electricity. And the next one, bad conductor of electricity. Or again, we are going to call here the insulators, conductors and insulators. So here, what it is, again the same thing. The substances that do not carry instead of heat, if you are going to consider what it is, electricity. The substances that do not carry electricity are called as good conductors of electricity. In the same way, what are bad conductors? The substances that do not carry electricity are called as bad conductors of electricity, or they are also called as insulators. So because of this property of the metals, what we are using is, we are using a copper wire for conduction of the electricity, and also these wires, and they will be covered with the plastic. The reason for that one is, if we are going to hold it, when the current is flowing through this, we are not going to get electric shock because plastic is insulator or bad conductor of electricity. In that way, here we have got the conductor, what it is, we can say material that allow electric current to pass through it. Example for that one, copper, aluminium, steel or any metal. Then insulator, example for that one is plastic, cloth, rubber, glass. So you have got 5 electrical conductors: silver, gold, copper, steel and also sea water. That means the water which contains salt. Then the next one, they are insulators: rubber, glass, oil, diamond and dry wood. So this is dry wood. It is an example for electrical insulators. In that way, we are going to consider the second property of the matter, what it is, electrical conductivity. Now we shall go for the next property, that is called as magnetism. So what is magnetism? The property of a substance to attract the substances like iron and cobalt. The magnetism, the property of a substance to attract the substances like iron and cobalt, that is called as magnetism. And we have got different types of magnet. What is a magnet? Magnet is a substance that is going to attract iron, cobalt and nickel. So here different shapes of the magnet. So it is horseshoe magnet or U-shaped magnet, circular magnet and bar magnet. It is cylindrical magnet, horseshoe magnet, and the next one is ring magnet. So here you have to know the difference between U-shaped magnet and horseshoe magnet. In case of this one, it is having the shape of U, letter U, but here this part is closely somewhat nearer to each other. And now I have brought the magnets also. So this is an example for what magnet? Bar magnet. And the next one, it is an example for round magnet. And this is an example for circular magnet. And apart from that one, this is an example for what type of magnet? Horseshoe magnet. And you have got the magnets with cheaper in price, so that you can play with the different shapes of the magnet. So you have got a magnet which is in this shape, and the next one, the shape of a magnet which is in the form of heart shape. So this is heart shape magnet. So like that, so many different magnets of different shape and different capacity you are going to get according to the things where you are using them. And now according to the property of magnetism, that means the substances that are attracted by a magnet and the substances that do not get attracted by a magnet. So here, when we are going to consider the property of magnetism, we are going to divide them as first one, magnetic materials. What are magnetic materials? The materials that are attracted by a magnet are called as magnetic material. In the same way, we are going to consider non-magnetic materials. So what are non-magnetic materials? When we are going to consider this definition, materials attracted by a magnet, then the materials that are not attracted by a magnet are called as non-magnetic substances. So here in the chart, you have got some of the magnetic and non-magnetic materials. When we are going to consider bottle opener and the needle, bottle opener made up of metal, so it is magnetic material, needle is magnetic material, glass non-magnetic material, wool non-magnetic material, scissors magnetic material, button non-magnetic material, paper clip also material, magnetic material, leaf non-magnetic, table non-magnetic, then screw it is a magnetic, eraser non-magnetic, nut it is a magnetic material. So here we shall see that again how we are going to consider magnetic and non-magnetic material. When we are going to consider this paper clip, so I am holding a magnet, you observe this, what happens to this paper clip? It is going to get attracted by the magnet, therefore it is called as magnetic material. Now I am going to consider the plastic. See, just if you are going to hold this near it, it is not going to get attracted by the magnet. And when we are going to consider the steel, what happens to the steel? It is not going to get attracted by the magnet. And the next one, glass. Glass is also not going to get attracted by the magnet. And this iron filings, You see the iron filings. What I have brought? I have brought the iron filings means pieces of iron. Then see how they are going to do. See here, when we are going to consider this, all these iron filings, they are going to get attracted by the magnet, getting attached to the magnet. Because of that, they are all called as magnetic materials. In that way, according to that property of magnetism, we are going to divide the substances as magnetic materials and non-magnetic materials. It is also the property of a substance. Then the next one that we are going to consider is expansion and contraction. So what is expansion? It is increase in size or volume of a substance. That is called as expansion. So expansion is increase in the size or volume of a substance. That is called as expansion. In case of the expansion, what we are going to see? We see the increase in size or volume of a substance is called as expansion. Then opposite of that expansion, it is contraction. What is contraction? Instead of increasing, it is going to get decrease. Decrease in size or volume of a substance is called as contraction. So here, when we are going to consider the increase in size and volume of a substance, they are not going to increase in size or volume by themselves. Only when we are going to heat the substances, when there is change in the energy of the particles, they are going to increase in the size and volume. How we are going to supply energy? Either by heating or by giving the passing the current through them. Then here we have got the experiment. What experiment it is? The experiment it is called as ball and ring experiment. So here, before heating, when we are going to consider this is the ring and this is the ball which is made up of metal. The size of the ball will be more and the size of the ring it will be less. Because of that, before heating, when we make this ball to pass through the ring, it will not happen. But after heating, what we are going to see, the ball is going to pass through the ring. The reason for that is when we are going to expand the ring, when we are going to heat the ring, it is going to increase in size. How we expand it? By heating. In the same way, expansion in the liquids. When we are going to consider this expansion, you can see the picture. We are going to heat the milk. What happens to the milk? It will spill out when it starts boiling. So here, the reason for that is increase in the volume. In the same way, expansion in the gases. When we are going to consider the balloon, where air is blown, if you are going to keep that in the sunlight for 2 or 3 minutes, what happens to that? The balloon increases in size and it is going to expand or it is going to burst. Or in this case, what we do, because it has got the elastic property, when the air is blown inside it, the size of the gases goes on, the size of the balloon goes on increasing. In that way, we are going to consider the example for expansion. In the next way, what we have to do, if we are going to cool these substances, again they will come to the original size. That means they are going to decrease in their size and volume. In the same way, when this liquid, that is milk, is cool, it will again contract, that is decrease in the size. In that way, the giving heat is a cause for expansion and contraction of the substances. So now, when we are going to consider the balloon also, in case of the balloon, again, when we blow the balloon, what we are going to observe? We are going to observe increase in the size of the balloon. So this is called as expansion. In that way, we are going to consider the different properties of the matter. So with this, I am going to conclude the lesson, states of matter. Thank you, children.